Hello everyone, welcome to today's class. So today we're looking at properties of a limit. Properties of a limit. Limit being the foundation of calculus, and understanding the properties of a limit is going to aid you in solving calculus. But today we're looking at properties of a limit. So properties of a limit. The first property says that the limit of a constant is the constant itself. The limit of a constant is the constant itself. For example, you have the limit of k when x tends to a is equal to k. So the limit of a constant is the constant itself. The second property of a limit states that the sum of a the limit of a sum of a finite number of a function is equal to the sum of their respective limits. The limit of a sum of finite number of a function is equal to the sum of their respective limit. For example, you have when x tends to a, f1 of x plus f2 of x plus f3 of x till infinity, fn of x. So this is equal to lim when x tends to a, f1 of x plus lim when x tends to a, f2 of x plus lim when x tends to a, f3 of x. So remember, it says that the limit of the sum of a finite number, the sum of a finite number of a function is equal to the sum of their respective limits. The sum of their respective limit, taking the limit of each term inside, taking the limit of each term, the sum of their respective limit. So the third property states that the limit of the difference of two functions is equal to their respective limits. The limit of the difference of two functions is equal to their respective limits. So this, for example, if you have lim when x tends to a, f1 of x minus f2 of x, this is equal to lim when x tends to a, f1 of x minus lim when f tends to a, f2 of x. So the limit of the difference of a function of two functions, the difference of two functions is equal to their respective limits, taking the limit of each term inside. So why the third property states that the limit of a product of a finite number of a function is equal to the product of their respective limit. Is equal to the product of their respective limits. Still the same thing as if we have lim x tends to a, f1 of x times f2 of x times f3 of x. So this is equal to, you take the limit of each term inside. Remember, it says that it is equal to the product of their respective limits. So this is limit when x tends to a, f1 of x times the limit one when x tends to a, just as if you take the limit of each term inside each term inside the expression. So we have the limit of f1 of x times f2 of x, f3 of x. So the fourth or the fifth property states that the limit of a quotient, you know what a quotient is? This is a quotient. When a number is expressed like this, a given expression like this called a quotient. So the limit of a quotient of two functions is equal to the quotient of their limits, provided that the limit of the divisor is not equal to 0, provided that this is always the divisor, this is divisor, provided that this divisor is not equal to 0, because if this divisor is equal to 0, everything in the expression will be equal to 0. So it states that the limit of a quotient of two functions is equal to the quotient of their limits, provided that the limit of the divisor is not equal to 0. So for example, we have lim when x tends to a, f1 of x divided by f2 of x. This is equal to, you take the limit of each term, the limit when x tends to a, f1 of x, and limit when x tends to a, f2 of x. So remember that this This law only satisfies when the divisor is not equal to 0, when f2 of x is not equal to 0. So understanding the properties of a limit is going to help you in solving calculus and to solve some further questions or further problem on limits. So on our next class, we'll tackle some problems on limits. So please like, subscribe, and share. See you in our next class.